Get ready for a cosmic adventure. Let's talk about the massive Jupiter, our solar system's biggest planet and a gas giant superstar. While we can't dive straight into its depths just yet, scientists have made some educated guesses about its layers, density, and mysterious core. But today, buckle up as we go beyond theory. Imagine launching a needle at near light speed towards this gaseous giant. It's time to put our knowledge into action. Let's explore some mind-blowing possibilities. What if we fired a needle at light speed towards Jupiter? Would it pop like an overinflated balloon or shrink so drastically that it becomes a mini black hole? Or maybe, just maybe, it'd blast off into intergalactic space. The truth is, though, our tiny needle wouldn't stand a chance against the sheer scale of Jupiter. At near light speed, it would slice effortlessly through the gas giant's outer layers like a hot knife through butter. You might think, hey, planes glide smoothly through Earth's clouds all the time. But when we talk about shooting a needle at light speed into Jupiter, it's a completely different ballgame. In under half a second, this super speedy needle would zoom from Jupiter's surface to its core, potentially piercing through a solid core made of one of the most extreme materials in our universe. Metallic hydrogen. This mysterious substance is what scientists believe makes up Jupiter's central powerhouse. Imagine the groundbreaking feat accomplished by Harvard scientists Isaac Silvera and Ranga Diaz. They successfully created metallic hydrogen in the lab, reaching mind-boggling pressures of 500 gigapascals, or 5 million times our Earth's atmospheric pressure. Though it only lasted a few seconds before disappearing, this discovery confirmed theories about Jupiter's core being packed with this mysterious substance. Now, envision what would happen if that needle we mentioned earlier struck the metallic hydrogen core at light speed. Could it set off an enormous chain reaction resulting in an explosion of unimaginable force? Hold on to that thought. Let's put things into perspective. The mass of a typical metal needle barely reaches 0.2 of a gram, while Jupiter's enormity is measured in staggering octillions of kilograms, making it as massive as comparing a human to a single-celled bacterium. You might think even the speediest objects wouldn't stand a chance against this Goliath. Surprisingly, history shows us that Jupiter has consumed much larger objects hurtling at incredibly high speeds, and they just got swallowed whole. Fast forward to 1990 for Shoemaker-Levy 9. A comet shattered into pieces, crashed onto Jupiter, only to vaporize in its atmosphere before reaching the core. Now, let's flip that thought around for our tiny metal needle. The faster it's moving, the more it'll be doomed. According to Einstein's theory of relativity, if our 0.2 of a gram needle somehow reached light speed, its energy would skyrocket, becoming almost boundless. So, when this speeding needle collides with Jupiter's atmosphere, boom, it instantly transforms into an enormous, shockwave-generating blast of energy. Hold up, let's not get too excited. Our needle may blow away Jupiter's entire gas layer, but it still wouldn't reveal the core. After all that drama, you'd expect to see this mysterious center, right? Nope. The truth is, without the crushing pressure of the atmosphere holding it down, Jupiter's metallic hydrogen core would essentially evaporate, just like when we create a plasma in our lab back on Earth, and poof, no core to be seen. So, unfortunately, our needle's cosmic speed wouldn't help us uncover any secrets about Jupiter's interior after all. So, how can we get our cosmic needle closer to the truth? Well, it's all about building an indestructible probe, one that can withstand some serious conditions. First, it'll have to slice through Jupiter's ammonia clouds like they're butter, and then enter a turbulent zone where winds are raging at over 120 meters per second. To put this into perspective, NASA's Galileo spacecraft took quite the tumble back in 2003 when it intentionally crashed into Jupiter. It started disintegrating even before hitting this wild wind speed zone. Our needle will need to be some kind of superhero to make it through this intense test. Our indestructible needle is still going strong. Next up, it'll dive into a thick layer of gaseous hydrogen mixed with helium. Think of it like a giant cosmic soup. Now, don't worry about our superstar probe getting hot from friction. It's designed to handle that. But here's the thing, all that friction will heat up the surrounding atmosphere. And in this scenario, we're talking about hydrogen. And guess what? Hydrogen is one of those rare elements that can ignite with just a tiny spark. Sounds like our needle might accidentally blow up Jupiter. Whoa, talk about fireworks on an epic scale. But hold up, there's a catch: oxygen, the other crucial ingredient for this explosive combo, isn't found anywhere within Jupiter. So while our needle might cause some serious atmospheric heating, it won't trigger a full-blown hydrogen bomb. Phew, the planet is safe, but just barely. But wait, there's one final hurdle for our indestructible hero. In Jupiter's upper atmosphere, lightning storms are a regular occurrence. Think of them as nature's own spectacular light shows. Now, you might be thinking, what's the big deal? Well, a metal needle would actually become a lightning rod, attracting these powerful electrical discharges with incredible force. And no matter how tough our needle is, it wouldn't survive that initial jolt. It'd get knocked off course and be done for. Plus, Jupiter has an even more formidable defense: its magnetic field. This colossal shield stretches out 7 million kilometers towards the Sun and a whopping 650 million kilometers towards Saturn. Even if we launched our needle at light speed, it wouldn't stand a chance against this cosmic force field. The magnetic field lines would not only steer it off course, but also trap it, making it Jupiter's latest tiny satellite. But here's the thing. Even at light speed, our needle would only make it around Jupiter once or twice before getting caught in its magnetic field. So, how can we outsmart this giant and get back on track? The answer lies in changing the material of our indestructible probe. Instead of metal, let's think about refractory ceramics. These super strong materials were actually used to build space shuttle hulls. Not only would a ceramic needle be 3 times lighter than its metal counterpart, but it also reduced the impact of Jupiter's atmosphere currents. That means we could launch our probe into a region where air resistance is minimal, giving us a fighting chance to reach the center of this gaseous giant. Now, what about targeting the Great Red Spot? It's got a reputation for being the calm eye in a stormy hurricane. But unfortunately, its center doesn't even come close to Jupiter's core. So, we've got to think outside the box. Earthly logic might say aim straight for one of Jupiter's poles, but this gas giant defies calmness. The polar regions are more like chaotic whirlwind zones, with thunderstorms brewing everywhere. Get this, Jupiter's equator is where our ultra-tough ceramic probe would thrive. Once launched, it'd cruise past those intense whirlwinds and upper atmosphere lightning storms. Then, thousands of kilometers deep, it'd plunge into a scorching sea of liquid metallic hydrogen. We're talking temperatures that range from a chill 6 degrees Celsius to a sizzling 20,000 degrees. Yeah, you read that right. As our probe hits this friction-filled layer, its descent would be dramatically slowed, and there's no way it'd pop out the other side. Instead, it'll likely get wedged in Jupiter's solid core, without even managing to compress it enough to create a black hole. But here's the wild card. Our high-speed probe could actually kick up a massive reaction in Jupiter's layers. As it zips through the planet at near light speed, it'd create an enormous disturbance that would mix and blend Jupiter's internal layers like you're stirring cream into your morning coffee. Even though we won't spot the needle itself, the chaos it unleashes on Jupiter's surface would be hard to ignore. Think gigantic storms wreaking havoc across the gas giant's atmosphere. If this all goes as planned, we'll have our proof a solid core exists at Jupiter's heart. But imagine if the opposite happens. A single, ultra-fast needle could potentially send shockwaves that destabilize the entire planet. Sounds far-fetched, but in this scenario, it's very real, and we'd essentially be looking at a cosmic demolition derby. Here's the thing. Scientists are still in the dark about how gas giants like Jupiter really work, and they're open to the possibility that its core is actually liquid rather than solid. Now, if we add to this the weird metallic properties of hydrogen at high pressures, things get really intriguing. If a needle were launched at light speed into Jupiter's heart, it could trigger a catastrophic chain reaction, destabilizing the entire planet from the inside out. The shockwave would reshape Jupiter's interior, causing its gravitational field to go haywire. And that's when things start getting really scary. In the blink of an eye, all of Jupiter's moons could be flung out of their orbits, careening into unknown territories in space. But hold on to your seats, because it gets even more mind-boggling. If this needle were to slam into liquid hydrogen at light speed, it'd create an unimaginable area of crushing pressure. And we're talking potentially catastrophic consequences that could send shockwaves throughout the entire solar system. Here's what could go down if a light-speed needle hits liquid hydrogen at Jupiter's core. It could trigger a nuclear reaction. Think sun-sized explosion. For a fleeting moment, our gas giant would shine like an actual star, lighting up the sky with an otherworldly glow and temporarily turning day into night. But don't be fooled. This flash of light wouldn't just vanish into thin air. Without that solid core to hold things together, gravity could get overwhelmed by the nuclear blast's sheer force, causing Jupiter to disintegrate into a massive cloud of gas that spread across our solar system like wildfire. Now, imagine what would happen next. Thousands of asteroids currently orbiting Jupiter, some huge, some tiny, would be set free, and their paths would intersect with those of Earth and other planets in ways we can't even begin to predict. Now let's think about this scenario if Jupiter were to suddenly vanish. Those thousands of asteroids in its orbit would go rogue and start hurtling towards our planet and others. With no Jupiter to keep them in check, their paths would be random, making it a game of cosmic roulette as they crash into Earth and the other inner planets. And that's not all. Without Jupiter's massive gravitational pull to stabilize things, our solar system would go haywire. The orbits of Mercury, Venus, Earth, and Mars would shrink dramatically, bringing them scorchingly close to the Sun. This means we'd be in for a whole lot more than just asteroid attacks. Extreme heat would become a deadly reality for all life forms. But here's the cool part. Scientists have actually run experiments on this very scenario. They've simulated launching a light-speed needle into Jupiter, which could potentially rip back the curtain on its enigmatic structure and help us finally understand what makes our biggest planet tick. Now, here's where things get really interesting and also a bit unsettling. The not-so-good news is that if we were to try and probe Jupiter with a light-speed needle, there's an equal chance, 50-50, that it could have some pretty catastrophic consequences for our home planet. In fact, the experiment could